Thanks for the introduction. Hi, everyone. My name is Cuong, and this work is done when I interned at Adobe Research, working with DiVerdi, Hertzmann, and my PhD advisor, Feng. So virtual reality video is emerging as a new medium for people to share experience. These videos are often made from 360-degree video. And when you view this video in the VR headset, like the Oculus Rift over here, you can freely look around and immerse in the story. Filmmakers are currently exploring and creating a wide range of content for VR video, including documentary, storytelling, or even interview. Now, a general process for making VR video usually starts from people planning and capturing 360-degree footage. And then on the post-production side, video editors would put together these 360 video and make VR video. Now, there may be other stages in the production pipeline, but my talk will focus on the editing side of VR video. So what's interesting about editing? It turned out that editing VR video is really hard. To understand that, let's look at how VR video is different compared to regular 2D video. Now first, VR video is really immersive. The viewing experience in VR is very, very different compared to viewing it on the desktop. When a person views video in VR, they can laugh, they can scream, they can reach out in midair. These things cannot be found when viewed in the desktop. So as a video editor, you have to consider how your editing would affect the viewing experience in VR, including enjoyment, presence, or even motion sickness. Second, perhaps the most unique aspect of VR video is that in VR, a viewer can only see a portion of the whole scene. So, for example, here's an eco-rectangular format, which is a common representation of 360 video on the desktop. Here, you can see that the viewer is looking at the cameraman, but he can just look down to this guy in this blue shirt. The freedom to look lies on the user, and the video editors cannot assume a viewer will look in any particular direction at any time. So traditional way to edit video like jump cut, zooming, directing attention usually doesn't work well and can even be jarring to watch in VR. Meanwhile, most video editing is still done primarily on desktop interface. For example, here you can see that the editor can load a 360-degree video. He can do some editing on the timeline. But still, if you really want to see how your edit look in VR, editors still need to put on the VR headset to view VR content in between edit, making editing a really frustrating experience. In general, editing VR video on the desktop is problematic because it creates this tedious workflow where editors have to put on and off the headset all the time to make changes and preview the edit. Also, interacting with VR video on the desktop can sometimes be unintuitive because editors have to use tools that were designed for 2D video and not 360 video. So in this project, we take the first step in enabling a video editing workflow for VR video directly in the VR headset. In commercial software, there are tools that allow you to edit 360-degree video, but for example, in Adobe Premiere or Metal Skybox. But they are mostly just modifications of existing desktop-based editing. Connecting our work to VR research. Most work in VR has focused only on 3D graphics or 3D environment, and we currently know very little about video UI or video interactions in VR. So by studying video editing in VR, we hope to learn more about how users can interact with video in virtual reality and what new interface mechanism can be developed to support them. And so in order to enable an in-headset VR video editing, we first interview 4 professional video editors in VR to learn more about their current workflow and identify what editing should be done in VR. Then we develop a video editing application called Vremiere and evaluated that prototype with an expert review study. In our interviews with VR filmmakers and editors, besides learning more about the challenges of editing VR video on a desktop, as I described earlier, we also need to identify what editing tasks should be done in VR. Now, why is that? Why don't we just implement everything in the headset? So video editing is a highly complex activity which often involves a lot of tasks. So it would not be reasonable to implement everything in the headset. For example, we believe that tasks like managing files, filling out form parameters, or assembly clip, should be done on the desktop because they require a lot of mouse and keyboard input, as well as a high-resolution display like on the desktop computer. Instead, we propose an in-headset editing workflow that can complement desktop editing. We envision that an editor can start working on a desktop, but then can perform certain editing steps in VR if he wants to. So based on our interview, we identified these tasks as the most important to be done in VR. And as a first exploration, we currently focus on these tasks, namely timeline editing, assembling cut, reviewing, and titling. So for those of you who don't know, titling simply means overlaying text or graphics on top of a video. These tasks are very common in many editing activities, and we believe they provide a good building blocks to study more this new editing, new form of editing. And we will leave the study of more advanced editing tasks like spatial audio and color correction for future work. With that, I present Vremiere. Now, Vremiere is an in-headset editing application developed for the Oculus Rift headset. Vremiere features a familiar timeline design with mouse and keyboard as input. Now, we chose the design because users who have already been familiar with desktop editing can pick up our system quickly. The interface of Vremiere is rendered on top of the video in the background, and it follows the user view as he looks around. In this way, the user can quickly have access to tools whenever he needs it. Looking closely at Vremiere interface, we can see that it has the look and feel of a familiar desktop editing software. A user can perform basic editing tasks like trimming or rearranging clips on the timeline. The clips are represented as multiple tracks for graphics, video, and music. Now you can see that our interface is minimal. We actually remove a lot of interface elements that are not needed in VR. Instead, we focus on developing dedicated tools to support editing video in VR, and I will talk about them in the next slides. So based on our interviews, these are the tools that we developed. First, I will talk about video navigation, which is perhaps the most common task in any editing activity. So video navigation usually means dragging the timeline or watching a video to find key moments. Now, in VR, your field of view is limited. So when navigating video in VR, an editor might not be able to see everything of the 360 environment. And this is problematic because for video editors, they frequently need to skim or find key moments in video to edit. So to support video navigation, our system provides a little planet visualization, which shows the whole surrounding of the video to user. Here's an example. In the center, the yellow fan is my current view. The visualization updates based on my head motion. And if I see something interesting, I can just turn my head directly to that direction and quickly find it and not missing it. Another important part of video navigation is comfort. Now, some video may contain a lot of scene motion, like sport video or hiking video. Viewing this video in VR can cause discomfort to user, especially during playback or scrubbing the timeline. To alleviate discomfort, we developed an adaptive vignette visualization, which was inspired by a recent work by Fernandez. When this tool is on, our system adaptively contracts a pair of vignettes around the user eyes based on how much optical flow is in the view and also based on how fast the user is dragging. For example, now the user is scrubbing the timeline. Our system can swing the field of view using the vignette and also effectively reduce the amount of peripheral motion that can cause discomfort in VR. Now let's talk about cut. Now in traditional cinema, cut is usually mean a transition from one scene to another, and video editors usually use cut to lead the viewer attention through the story of the video. But in VR, user can look anywhere. So it's actually quite difficult to align the user attention, the viewer attention before and after the cut. Let's look at this example. So in this video, I'm looking at a group of skiers. I'm expecting to see some interesting skiing action after the cut, let's say. After the cut, what I ended up is just this empty, boring scene of some snow. This is really not what I expected. So what's happening there? It turned out that when you look at the equirectangular format of the previous cut, after the cut, the user was not looking at the main object of the video. And this is a unique problem in VR video, and video editors frequently need to find ways to rotate the video and try to align interesting objects before and after the cut, so that they can make so that they can make the cut more interesting to watch or the story more continuous to follow. So to support that, we have this rotation alignment tool that can visualize the alignment of the video before and after the cut. So this is a clip before the cut, and this one is after it. The yellow bar is my current view, and user can also scrub directly on the clip on the visualization to align interesting points together. Now the cut has been aligned. Let's watch it again. Now we just cut from human to human, and I think that was certainly a better way to do the transition. For reviewing, on desktop, video editors frequently use timeline markers to communicate with their clients or producers. Markers are also useful for many other tasks in editing. VR video create a new requirement for markers, because people are working in VR, people are working with a 360 environment. Editors now need to mark not just when, but also where an event happens in the video. And our system allows a user to directly add marker to the video. Now, for example, when the marker tool is on, the cursor becomes change the icon to a pin, and user can just throw marker on the video. Each of these markers record both the time of the video and the orientation of the view, so video editors can quickly review them later. Finally, for titling. Now, adding 2D graphics such as title or images to VR video is often unintuitive on desktop. Video editors often work with the equirectangular format, and when you add text or images to this representation, the text can become really distorted. More important, it's also really difficult to have a good understanding of the size and the position of 2D graphics on the video unless you can see it in VR. So our system provides a natural view of the 2D graphics and allow editors to directly place it anywhere on the video. Now, we conducted an expert review study to evaluate our system, how it can support VR video editing. We recruited 6 professional VR video editors from local studio. We asked them to produce a travel video for the Oculus Rift headset. For the task, we gave them 4 360-degree video footage of different cities, a music soundtrack, and a logo file. We collected ratings and subjective feedback as a result, and I will highlight some results now. For more details about our study, please refer to our paper. When we asked experts to compare VR video editing with their current workflow, we found that experts demonstrated preference for several in-headset editing tasks, like being able to preview and edit video directly in VR, being able to rotate and align cut, and also titling. Also, when we asked them to rate the usefulness of some editing tools that we developed, we also found that experts found some of our tools, such as rotation alignment, titling, and adaptive vignette, helpful for their editing need. So these results are encouraging, but our work is just a first step in supporting VR video editing. We think that there are a lot more opportunities for future research. First, for example, we can study how to develop or design more advanced in-headset editing features like color grading, keyframing, spatial audio. Second, nowadays in VR, we have all kind of expressive input device like the touch controller, hand gesture. I think it would be interesting and also important to consider how user can interact with VR video in future. And finally, our system currently support monoscopic video, and it will be also interesting to consider how to support stereoscopic video in future. And that concluded my talk. Thank you for listening.
Thank you. That was a great talk. Questions, anyone? Okay. So I have a question.
Sure.
So what do you think it would take to make this a low-cost setup? How do you, let's say, so we're looking at expensive VR editing software at this point, right? If we were to make this sort of easily editable, what do you think are the steps to kind of get to that stage?
So is your question, let me rephrase. Did you ask about like how to make editing VR video easier?
Easy, low cost.
Easy and low cost?
Yeah. Or let me rephrase this. What are the literacies you think are required for someone to do this kind of editing?
Okay. So yeah, so right now our prototype run on the Oculus Rift headset, and I realized that it is quite expensive to set up, but our design actually very minimal. It doesn't require a lot of like expensive tracking. It only need rotation sensor. So with the design and the setup like that, I think it can also run in like a Samsung Gear VR, for example. So I think cost would not be a problem. I think we should focus more on how to make the whole process easier, and there are a lot of work to be done in this space, I think.
Awesome. No, thank you. I enjoyed your talk.
Sure, thanks.
Hi, I'm SIGCHI from Google Research. Great talk and great work.
Thank you.
So I'm wondering, given that now we have more content analysis and understanding, we can automatically label the video, even maybe 3D videos. What are your thoughts on if we can include more intelligence and automatic editing or suggestion during this process? For example, you gave the example like manually align the human, where is the points of interest. But say if we have the face recognition, then maybe when you do the cut, and you can automatically suggest the orientation. So just some thoughts.
Yeah, that's a really good question. Thanks for raising that. So my thought about that is also, we should go back to regular video. So editing regular video is also hard, and people come up with own kind of do automatic editing for regular video. But I would say that we rarely use that. People love editing for one reason. It's a creative process, and I would leave the job for the filmmaker to do that. And for automatic process, I think it's more important to have the system assist the video editors instead of getting in the way of editing VR video. Did I answer your question?
Yeah, thanks.
Thank you.
Thank you. We'll move